So here is a problem, same as the transmission line, and we are going to analyze the single phase transmission line, and of course we'll determine the total inductance of this circuit. So A circuit is represents the go and B circuits represents return, and within the A circuit these three conductors have radius of 2.5 millimeter each, and for B circuit D and E, these two conductors or cable radius is 5 millimeter of each, and of course as I said we have to calculate the total inductance L. The empirical equation of L is equals to 2 into 10 to the power minus 7 ln GMD over GMR. Let's start with GMD. So here the A circuit have got 3 conductors and B circuit have got 2 conductors. Indeed 3 times 2 square root of course here 2 times 3 means 6, so here will be 6 distance 1, distance 2, distance 3, distance 4, distance 5 and distance 6. So what is distance 1? Let's describe here. So from A, let's say this is distance 1, and from A to E, let's say this is distance 2. From B to D, this is distance 3, and from B to E, let's say this is distance 4, and from E to C, this is distance 5, and of course from D to C, this is distance 6. So step by step we are going to understand how we determine these 6 distances by using precise description of the images. So here distance A to D and D to B, and from B to E, and from E to C, these 4 distances are all equal. So let's find out the distance between A to D. So let's draw from A to D this one, distance 1, or let's say this is distance AD we have to determine. Okay, and from A to B this is 4 meter, so of course up to this one will be 2 meter, and from here midpoint of this 2 up to D, this is 8 meter. So distance of AD is equals to square root of 8 square plus 2 square. So we have square root of 68. It means distance AD is equals to BD is equals to BE is equals to CE. All these 4 are equal, so this is square root of 68. Okay, another distance from D to C. So from D to C, this is of course a hypotenuse of a triangle from the midpoint of AB here. So from here to here is 4, so up to this is 2 meter and this is 4, so all together this is 6 meter and this is 8 meter. So the distance DC is equals to square root of 8 square plus 6 square. So we get 10 meter. Same as the distance from A to E. So distance A to E is equals to square root, as this is hypotenuse, we have to evaluate from A to E, and of course this is a right angle triangle. So up to from here to here the distance is 6, because of from here to here is 4 and this much is 2, so 6. So same as distance D of DC and distance D of A is 8 square, because from here to here is 8 meter. Here is the given from the question, and from A to midpoint of BC up to this much is 6, so 6 square, so this will be 10 meter. So what we have, so here will be square root of 6 and D1, I mean here 4 distances are square root of 68, so it will be square root of 68 to the power 4, as 4 distances are same as square root of 68, and another 2 distances, that is 10, so there are 2, so it will be the value of square. So 4 and 2, this is 6 altogether, 6 different distances. Total GMD for the circuit will be 8.793, of course meter, by the way. So this is the GMD. Now let's start to calculate the GMR for the circuit A and circuit B. So it's time to calculate the value of GMR. So GMR for circuit A, and here the value of the conductors or the cables, let's say M is equals to 3, and for B, N is equals to 2. So GMR A is equals to, so the value of M is 3, so 3 square root, and of course here will be 9 different distances, right? So D1 to D9 distances will be within this circuit A. So 3 square means 9, of course. And now for the distances, how many distances? First of all these 3 equal conductors, for that individual strand distance for R1 or R prime is equals to e to the power minus 1 by 4 times the radius R, and R is 2.5 millimeter. Indeed, here we'll get 0.7788 into 2.5 millimeter, right? So from the calculation we'll find 1.947 into 10 to the power minus 3. How many conductors? 3. That's why here Q. And the distance from A to B is 4, same as B to A is 4. Again, B to C is 4, C to B is 4 as well. So 4 of 4 distances, that's why 4 to the power 4. And from A to C is 8 and C to A is 8, so altogether 8 square. Now calculate this value. So the value we found, that is 0.367 0.367 meter. Now for circuit B, of course 2 square, because 2 cables 2 square, and here will be 4 different distances. So D1, D2, dot dot D4 distances. There are 2 conductors. So these 2 conductors, the individual distance e to the power minus 1 by 4 times the radius. And here the value of e to the power minus 1 by 4 is equals to 0.7788, and the radius is 5 millimeter. Okay, so altogether this value we found 0.0034 meter, right? So here let's plug in the value. Okay, so this will be 4, and individual distances for D and E cables or conductors, that is 0.0034 to the power 2, because there are 2 conductors, that's why square. And the distance from D to E is 4 and E to D is 4, so 4 square. So we found the GMR for B circuit, that is 0.1248 meter. So now we already have calculated the value of GMRB. Now we have to plug in the value of GMD, which is 8.793. So let's write down here the value of GMD is 8.793, and GMRA is 0.367 meter. And let's put it here, the value of GMRB, that is 0.1248 meter, right? Now let's find the value of inductance LA and of course LB. Equation is 2 into 10 to the power minus 7 ln. GMD is 8.793, and here same 2 into 10 to the power minus 7, and here ln value will be same for GMD 8.793, and for LA, that is this one, 0.367, and here will be 0.1248. So after calculation have done, we will find the total inductance, that is LA plus LB, so that will be 1.485 millihenry per kilometer. So this is our final answer.